Good morning, everyone. Welcome back to the another session. This video is about graphs. This video will be going to learn about graphs, and this video will cover two concepts. The one is introduction to graphs and terminologies of graph. So these two topics we'll cover in this video. Now let's talk about the first, what is a graph? That is introduction to a graph. Right. Before of this graphs, we were already completed our discussion about trees. So for appearance, trees and graphs will have similarity in nature. That is, look at this. Now we will call this as a tree, right? Now the same thing I can call as a graph. Now look at this. And this I can call as a graph, but not I can call as tree. Now you can understand the difference. A tree is a nonlinear data structure where it will be arranging in this tree will be arranging the elements in hierarchical fashion without a closed surface. This is what tree definition, right? And look at this. Graph is a nonlinear data structure. Graph is a nonlinear data structure where it will consist of vertices and edges, and the construction of this graph will be maybe in a closed surface. These 3 points. Graph is a nonlinear data structure where it will have vertices and edges. That is set of V comma E pairs. Whereas V is vertices, E is edges. This is what graph definition is. Okay. Now let's take the example for the better understanding. Now look at the example that I'm having 0, 1, 2, 3. Now these 4 nodes are called as vertices. These 4 nodes 0, 1, 2, 3 are called as vertices. Now let us assume G is a graph, then G is equal to V comma E, whereas G is a graph, V is vertices. V is vertices and E is edges. Now what are vertices here? V is equal to, what are vertices? 0 is a vertex, 1 is a vertex, 2 is a vertex, 3 is a vertex. So V is equal to 0, 1, 2, 3 are the vertices. Now edge. G is equal to, graph is equal to V comma E, right? V is number of vertices. These are vertices. Now what is E? E is equal to E is equal to the connection in between two vertices. The connection in between two vertices. Now look at the graph. If I am having a link in between these two vertices, now this is an edge. If I am having like this, now this is a graph. G is equal to V comma E. Now identify the vertices. This is an edge in between 0 and 1. Now it will be pair of vertices and edges, 0 comma 1. And 0 is having the other edge from 0 to 3. one edge is from 0 to 1. This is one edge. Okay, and the other edge from 0 is to 3. So now 0 comma 1, 0 comma 3. And now look at 1, and no more edge from 0. Only we have two edges, so we represented two edges. Now look at 1. 1 is having three edges, 1 to 0, 1 to 2, 1 to 3. 1 comma 0, 1 comma 2, 1 comma 3. Now look at 2. 2 is having two edges. One is from 2 to 1, the other is from 2 to 3. 2 comma 1, 2 comma 3. Now again look at 3. 3 is having three vertices. 3 to 0, 3 to 2, 3 to 1. 3 to 0, 3 to 1 and 3 comma 2. These are what a graph is. Graph edges. Now what is a graph? G is equal to V comma E. Vertices, edges. Every node in a graph is called as vertices or vertex. And the connection in between two vertices are called as edge. Now these many edges we found from the above graph. Okay. Now let us see terminologies of a graph. Terminologies of a graph. Right. The first terminology is vertex. The first terminology is vertex. Now just now we were seen, right? What is vertex? Node in a graph. Node in a graph is called as vertex. Okay. Now let us see the example. Now can I call this as a graph? Yes, it is a nonlinear data structure where it is having collection of vertices and edges, and it is constructed in a closed surface. Right? It can be constructed in an open surface, that the closed loop may not be there, but if it is there also, it's okay. We will be calling it is a graph. Same thing is not applicable for tree. If you have any questions in tree, you can see my previous videos about introduction to trees. Now look at this, and the second terminology is edge. Now what is edge? Edge is the arc or link or connection in between two vertices. Now just now we were seen about the same, right? That 0 comma 1 is a edge. 0 comma 3 is one more edge of 0 vertex. Now look at 1. 1 is also having three edges. One is from 1 to 0, 1 to 2 and 1 to 4. Now look at your 2. 2 is having edges from 2 vertex. 2, 2 to 1, 2 to 3, 2 to 4. And 3 is having two edges. 3 to 0, 3 to 2. And 4 is having two edges, 4 to 1, 4 to 2. This about your edge. Okay. Now the third is degree of a vertex. Degree of a vertex. How to calculate degree of a vertex? That is the maximum number of edges. The maximum number of edges from a vertex. Now let us calculate degree of each vertex in the graph. That is degree of 0. 0 is a vertex. Degree of 1. degree of 2, degree of 3, degree of 4. Now let us see. Now look at your graph. 0 vertex. How many edges 0 vertex is having? Keenly observe. 0 is vertex and it is having 2 edges. One is from 0 to 1 and the other is from 0 to 3. So 0 is a vertex which will have maximum number of edges 2. So degree of 0 is 2. Now degree of 1. Now look at look at one vertex. 1 is a vertex where it will be having the maximum number of edges of 3. 1, 2, 3. 1, 2, 0, 1. 1, 2, 2, 2. 1, 2, 4, 3. So degree of 1 is 3. Now look at degree of 2. Go to vertex 2. Now this is your vertex. Now how many maximum number of edges 2 is having? 2 to 1, 2 to 3, 2 to 4. So degree of 2 calculated as 3. Now degree of 3. How many edges? 3 to 0, 3 to 2. So 2 edges. Degree of 4. How many edges? 2 edges. So these are what degree of a vertex. Degree of a vertex will be calculated like this. Now, size of a graph. Size of a graph. That is defined as the maximum number of edges. The maximum number of edges. The maximum number of edges a graph can consist. A graph can consist. Now look at this. How many number of edges it is having? Now just now we noticed the same, right? These are what the number of edges from the graph. This is other diagram and this is other diagram, right? Now let's write the edges. Tell me 0, 1 and 0, 3. 2 edges from 0 vertex. Now 1 vertex 1, 0, 1, 2, 1, 4. Now 2 vertex 2, 1, 2, 3, 2, 4. Now 3, 0, 3, 2 and 4, 1, 4, 2. Now look at this. How many edges? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. The size of the graph is equal to 12. That is what the total number, the maximum number of edges a graph can consist. And the fifth one, path. The path. The path is the maximum number of edges. The maximum number of edges from source vertex to destination vertex. Source vertex to destination vertex. What is path? The maximum number of edges from source vertex to destination vertex. Now look at the graph. If you wanted to calculate a path from 1 to 3, that means 1 is my source vertex, 3 is my destination vertex. As far as graph is concerned, you can start any node as the first node. As far as graph is concerned, you can start any node as the first node. If it is a tree, the first node is a root node. If it is a graph, you can take any node as your first node. So right, now I am taking this one. Now 1 is my source. Now you can choose any of the destination. Now my destination is 3. Now what is the path to reach from 1 to 3? I can travel from 1 to 2, 2 to 3. Okay? Or else I can travel from 1 to 0, 0 to 3. What is the path? The path is, now my source vertex. Source vertex from the example is 2. Destination vertex is 4. Now how to reach 2 to 4 from the above graph? 2 to 0 to 4 or 2 to 3 to 4. These two are called as path. These are called as path. Okay? And we even still we can calculate in degree of a graph, out degree of a graph, in degree and out degree. We can calculate these two in a graph. Now consider a graph. Now look at, this is my graph. This is my graph. Now what is in degree? In degree of a node. Now for example, I am taking 2. I wanted to calculate in degree of 2 vertex. I wanted to calculate in degree of 2 vertex. Now look at this graph. Now this is my vertex which I am considering to calculate in degree. So how many edges are coming towards of this vertex? How many edges or how many links are coming towards of this vertex? So you can see only one edge is coming from 1 to 2. So the in degree of 2 vertex is 1. Okay? Right. Now, out degree. Out degree means what? Let's see for all other vertices for the better clarity. Now, what is in degree of 0? In degree of 0, 1, which is from 3. Just now I told you that in degree is how many edges are coming to this node. So this node only one edge is coming towards to 0. So in degree of 0 is 1. In degree of 0 is 1. Now look at your 1. In degree of 1 is what? 0 to 1. Now that is in degree of 1 is 1. Now in degree of 3 is what? No link is coming, no edge is coming to 3. So in degree of 3 is 0. Now let's see out degree. What is out degree? Out arc or outside which is going from that. In degree means which is coming towards of it and which is going out of it. Now what is the out degree of 3? 2. One connection or one edge is moving from 3 to 0, out degree. From 3 it is going out. From 3 it is going out. So out degree of 3 is 2. Out degree of 3 is 2. That's what. In degree is inflow to the vertex. Out degree is outflow from the vertex to the other vertex. Right. These are what the graph terminologies. Now let's have a look. Graph terminologies. Vertex, edge, degree of a vertex, size of a graph, path, and in degree and out degree. Okay. Right. Now the next video will be going to do on representation of graphs. Okay. Thank you all.